This video is about the slope-intercept form and practicing that as well as a little bit of graphing, just a smidge. So here we go. Here's a little bit of graphing. So you need to remember some things about slopes. Okay, you remember a positive slope goes uphill from left to right. A negative slope goes downhill from left to right. And then there's undefined, that's a vertical line. And then a zero slope is horizontal. Okay, so can you remember that? Well, the zero has the flat horizontal lines in the Z, right? There's your horizontal line. Undefined starts with a U, which is two vertical lines, right? So that may be helpful in remembering undefined versus zero. Negative and positive, you just got to know them. You should have learned this years ago, but this is your review. Jot it down, learn it. So this is helpful when it comes to graphing these lines, because look, I thought we were talking about slope-intercept form, right? Y equals mx plus b. Well, this is slope-intercept form, except it's a little weird because the slope is not as apparent as it used to be because there's no x term in the equation. See how this has an x right here? But there's nothing x here except this, and that's weird. And over here, there's no x at all in example 2, so what the heck? Well, here's what you need to remember. If the equation is not a y equals equation, or if it's an x equals equation, that simply means it's a vertical line. And let's think about that. If our slope of vertical lines is undefined, that means that you are going to have no x term in your equation. So this is the whole equation. This is all it is. Because think about this. A vertical line, unless it's at 0, is not going to cross the y-axis at all. So how would I graph this? Well, here's my grid. Now you're going to use a straight edge and make these really nice and neat. It's hard to do with this little tool. But here's my grid. Now x is positive 3, so I'm going to mark 1, 2, 3. And I know because it's x equals, it's a vertical line. So I'm going to draw my vertical line right there. And that is the entire graph of the whole equation. That's it. X equals 3. Another way to remember this is because it's x equals 3, it's going to cross the x-axis. So that's what it's doing right there. It's hard for you to remember vertical versus horizontal. If it's x equals, it crosses the x-axis. Now, so look at example 2. It's not x equals, it's y equals. Well, if y equals negative 2, what about the rest of the equation? Doesn't really matter, because if it's y equals, it has a 0 slope. It's horizontal, crossing y-axis. Okay, so here's my grid, nice and neat. And it's at negative 2, so I go negative 2, down 2, and I draw a nice, neat horizontal line crossing the y-axis, and that's my graph. That's all there is to it. Okay, so you got to pay attention to what it is. Is it y equals or x equals? Because that determines the direction. Okay, so you have a couple of little of those just to refresh your memory on your slopes, especially the vertical and horizontal lines. Now, find the next section here. Find the slope and the y-intercept, if possible, of the equation of this whatever line they give you. Remember that the intercept is a point. Okay? So in your answer, you're going to give me a point for that y-intercept. Okay? So I need a slope and I need a y-intercept. That's my goal here. So if I look at my equation, remember the generic one says y equals mx plus b. M is my slope. It is the coefficient of x. Make sure you learn that word, coefficient, the big number beside x. That's coefficient. So in this case, my m is a 5. My slope is a 5. B, remember, stands for y-intercept, and that's the point at which it crosses the y-axis. So B is 3, but that's not the y-intercept. Remember, the y-intercept is a point, so it needs to look like a point. Well, if it's crossing here at 3, what's that point? That point is at 0, 3, right? That's my y-intercept. So this is the way you need to record your answer, making sure you don't tell me that the y-intercept is 3, but it's actually a point, 0, 3. So look at number 4 here. 7x plus 6y equals 30. Well, that's not in y-intercept form, so I first of all have to rearrange this equation to get y by itself. before I can determine the slope and its y-intercept. So I'm going to move things around to get y by itself. So I'm going to subtract 7x from both sides. Start there. So I have negative 7x plus 30. Then I need to divide every term by 6. So y equals negative 7/6 x. 30 divided by 6 is 5. So I always reduce that. So then I can analyze, what is my slope here? Well, what's the coefficient of x? The number with the x. Well, that's negative 7/6. And the y-intercept is a point, recall. It's 0, comma something, and that something is right there. That's the 5. Okay? There's your y-intercept. Again, doing the same thing as we were before, remembering that the intercept is a point. All right? Example 5. So I need to solve it for y first. So I need to add 3 to both sides. So y equals 3. There's my line. Now let's think. What's my slope? What's my y-intercept? Now here's where that graphing thing comes back to help you. What does that look like? A y equals 3 line. Well, since it's y equals, it has to cross the y-axis at 3, right? Okay, so it's a horizontal line. What kind of slope does a horizontal line? Well, it has the horizontals like a z for 0. My slope is 0. The y-intercept, what's that point right there where it crosses the y-axis? Well, it's 0, 3. All right? That's how you work that one. Look about this one. X plus 5. Well, there's no y. What do? Well, solve it for x. So x equals, you're going to subtract 5, so x equals negative 5. Again, you run into issues here. Well, if I graph this, if it's x, that means it crosses the x-axis at, and this is negative, negative 5. Okay, so there it's a little squirrely, but you guys use a straight edge. At negative 8. So it's a vertical line. I know the slope of a vertical line is undefined, so I substitute u for that. Undefined because it's vertical. So my slope is undefined. What about the y-intercept? Where does it cross the y-axis? Well, here's my y-axis way over here. Is it ever really going to cross that? No. It's parallel, so it's not going to cross it. So you would just say none. Simple as that. None. Find the slope-intercept form of the equation, a line that passes through the given point and has the indicated slope. So this is giving you some information. This is where I would use, in this case, on example 7, I would go back to my point slope knowledge, where I used this formula a couple days ago, maybe yesterday. This one. So I would plug in my m and plug in my point. So here's x1 and y1. So I would say y minus 0 equals negative 1/3 x minus 4. All right? Now remember we said before, if there's a fraction for the slope, the way to get rid of that fraction is move that 3 over to the left side. And I would leave the negative with the 1. Don't put the negative with the 3 and the 1, but just put it with the 1. Now I need to distribute out. 3y times 0 is going to be nothing, so we'll leave that alone. So I have negative x plus 4. I need to get y by itself, so I'm going to divide by 3 all the way back through the whole thing. So I have y equals negative, now remember there's a 1 in front of that x, so you can say negative 1/3 x plus 4/3. And that is my slope-intercept form of the line. Now what about number 8? It says 6, negative 1, so let's graph this. 6, negative, that's roughly right there. The slope is undefined. Well, remember what that means. That means it's a vertical line. It goes like that, right? It has to go through that point. So there's my graph. So if you remember, vertical lines means it's an x equals line, right? So all I have to do to write the equation is x equals, and then consider what is that x coordinate right there? Well, you got it from the point. We got it from there, so x is equal to 6. And that's really all the calculation you do. It's just thinking visually what's going on here. It's a vertical line crossing where x is 6. Find the slope-intercept form of the equation of the line that passes through this point and has this slope. All right, so think, before you start trying to do a bunch of math, think, what does the slope of 0 look like? It is a horizontal line, isn't it? It's horizontal. So it's crossing the y-axis somewhere, right? Well, it's crossing where it's 5 halves, isn't it? So where's that y? 5 halves. X is at 4, that's like over here somewhere. Well, it goes through that point, sure enough. It's just a horizontal line. So how do you write that as an equation? Well, you can do the old x1, y1 thing if you're more comfortable. You go y minus 5 halves equals 0 times x minus 4, and clean it up. Y minus 5 halves equals 0, right? And then move that y over, and that's your equation. Some of you can just look at the graph and know, okay, it's just y equals 5 halves, because visually what's going on. Some of you need to show the work. I get that. It's a little tricky. Let's try one last one. Has all the elements of this week in it. Find the slope-intercept form of the line passing through these points. M is your slope. So if I need to calculate that, I'm going to say negative 4 minus 2 over 3 minus a negative 1. Negative 6 over 4, which reduces to negative 3 halves. Always, always reduce. So then I'm going to pick one point, it really doesn't matter which point, and plug it into point slope form. So y minus 2 equals negative 3 halves. X minus negative 1 makes it plus 1. So y minus 2, I'm going to get rid of the fraction, so I'm going to put that 2 out here. Now I'm going to distribute both sides. Now my goal is to solve for y, so I'm going to add 4. Negative 3 plus 4 is a positive 1. Now I have to divide through by 2. So I know you shouldn't go to side, but I run out of room here. So my answer will be negative 3 halves x plus 1 half. All right. I hope this rings a bell from algebra. Hope you're doing okay with it. Ask me questions in class. Make sure you've taken great notes.